Boom! Yes folks, Hume here again. So in this video we're continuing with our series on completing the square. In this video we're going to work out some actual questions where we do a whole quadratic expression from top to bottom where we completing the square. Basically what we will be doing by way of revision is switching from the standard form to the vertex form of the general quadratic equation. Alright, now if you recall, we still at the level where in terms of the general quadratic expression ax squared plus bx equals c, a is equal to 1. So in other words, the coefficient of x squared in the quadratic is still equal to 1, and we're still dealing, yes, with the positive coefficient of x squared. So we increasing the difficulty incrementally, and we're doing that to give everybody a chance to really master this topic. This is one of the topics which, if you master it, your confidence will just go through the roof and it will feed into other topics in the maths. Alright, so we go in. So suppose we get an expression and they ask us to express, let us say, x squared plus 6x minus 7, and they want us to express that in the form a into x plus h squared plus k, right? Remember, this is the vertex form that we started off with, right? And of course, they will usually ask you to state the value of a, state the value of h, and state the value of k, where those three values are constants in the vertex form. So, watch it. We start here, and let me just switch the color of the ink here now for emphasis. We switch, we try the green right here, right? We take this. We'll find a name for that just now, right? And we write that over as x plus 3, all in brackets, to be squared, minus 3 squared, minus 7. In other words, we take this and we write it over as x plus 3, all to be squared, minus 3 to be squared. And we could do that not because we cramming. Of course, we know some people going to cram it, right? But even in the cramming, there is a system, right? Because to move from here to here, we have half the coefficient of x inside here, and then we just take that same whatever we have inside here and we square it with the minus sign here, and that's it. That is it. So we could just apply that. I don't want to use the wrong one here. We could apply that in a kind of automatic sense when we have to complete the square. But even as you apply it automatically, it is important that you know where we get it from and how we get it. And that is why I am doing this video in a series. So we start from the very top and we go right through to the bottom. Alright, so we continue. So x plus 3 all to be squared minus 3 squared, and at that case we leave it like this. X plus 3 to be all to be squared minus 3 squared is still 9, minus 7, which will give you x plus 3 all to be squared minus 16. And if for the sake of argument we want to work this backward, just to verify that we will get the thing. So in other words, if we work it backward, if we start from here and we work it backwards, we expect to get this on top here as the final answer. So let me try it. So suppose we take x plus 3 to be squared minus 16, and we want to see what we get if we work that backwards. Alright, x plus 3 all to be squared is x squared plus 6x plus 9 here, and then minus the 16 there. 9 minus 16 is minus 7, so you get x squared plus 6x minus 7. Alright, so you see that it worked out very quickly, no problem there at all. Alright, so I'm going to rub this off quickly. You've seen it on the video. You always have the option to pause, to rewind. So we go in. Next question. So again, we have the format up in the corner there. That is, I didn't state the values of a. Let me see. I didn't state the values of a, h, and k. Right. So just for the record, I'm going to do that now. So in that last question we just did, just for sake of revision, we had x squared plus 6x minus 7, and that worked out to be x plus 3 or to be squared minus 16. In this case, a is equal to 1, 8 is equal to 3, and your k is equal to minus 16. So in other words, you have to be prepared also to state the values of the function of the constants in the vertex form, because a lot of times that is actually requested. So we're going to proceed with the next question now. Alright, we make a quick swipe here and we're going. So suppose we have to express, let us say we have the expression x squared minus 12x plus 27, right? And they ask us to switch this from the standard form to the vertex form, better known as completing the square. So again, we take this little piece in this little bit here, alright, and we express that as a difference of two squares, meaning we take this and we express it simply as x squared, x minus 6, sorry, all to be squared minus 6 squared, and then I could put plus 27 there. Alright, so that would be, and you work it out now, 6 squared is still 36, so x minus 6 in bracket all to be squared minus 36 plus 27. Minus 36 plus 27 will be minus 9, so you got x minus 6 all to be squared minus 9. So you start to see here where if you're having problems with negative numbers in a general sense, which is the case for some people in mathematics, then even if you're able to get here, then getting from here to here could be a problem, right? What some people will do, they will make the mistake of writing this over as minus 6 squared, and then if they put minus 6 squared, somehow they will square minus 6 and get minus 36. So that is why, in a very general sense, what I would suggest is that they put the 6 here in brackets, even though in this case it is an integer, because an integer, having been derived as half of an odd number, an odd coefficient of x over here. So if you have an odd coefficient of x here, we divide it by 2, we're going to get a whole number. We're going to move on very shortly to what will happen if we have an odd number up here. Alright, so just to be safe, you could do this. We took the liberty of not putting the brackets because it was an integer. But if you're now learning the topic and you're kind of wobbly where these things are concerned, we want to err on the side of caution. Put your brackets. So again, if you want to work this backwards and see what we get, we take the same route that we took in the last question. So we start off and we say, well, what will happen if I take x minus 6 all to be squared and a minus 9 from it? Right, so we're starting back from here, starting from the bottom. So x minus 6 in brackets all to be squared is x squared minus 12x plus 36, sorry, right, yeah, plus 36, and then the minus 9. So 36 minus 9 is still 27, so you'll end up with x squared minus 12x plus 27. So you see, we end back up where we started. Now, a little note here. In an exam setting, it is unlikely that you will want to spend time going through this, right? Because that will take up extra time that you could use doing something else in an exam. If you have the extra time and you want to do it, fine. If you don't have the time, what we aiming for, is that the algebra here would have been perfect. So by the time you get here, you know what the answer is, and you could proceed with a certain level of confidence going forward. All right. So that is it. These last two questions have been cases where we have even coefficients of x up here. We divide by 2, we get an integer. So now, let me see. Should I put that in a separate video? Yes, I'll put that in a separate video. So in the next video, we're gonna do the same exact thing, but we're dealing with odd coefficients of x. All right. So look out for that coming up. Stay tuned. and see you in the next video.